Hello, everyone. Welcome to today's webinar. We're here today with Ian Koutsoris talking about Git-Like branching for your data lake. Those of you who wandered by the Delta repositories throughout your careers or lives, I think Ian needs no introduction. For those of you who don't browse GitHub, Ian is one of the most prolific contributors to Delta Lake. I would say modern Delta Lake wouldn't be what it is today without him. Shaped Python integration to a tremendous extent, but also contributed throughout the entire code base. So I'm really excited to have him here today. Scott and I are always eager to hear about cool, interesting projects. And I think this is one of those. And yeah, Jon, thanks for being here. Take it away.
All right. Yeah, just to give a short introduction about myself, what I do in my daily life. I'm a data engineer, but I mostly do Kubernetes lately, DevOps, and other kind of ML-related tasks in the data science team. So I think we can get started, right, with the slides?
Yes, sir.
All right, so today, just as Robert introduced, we'll talk about LakeFS and Delta Lake and how these things can work in synergy. So we'll first start about talking about what is LakeFS actually, what kind of workflows can it support, and while doing that, I'll give some examples of process problems it can solve for certain data engineers or data scientists. Then we'll talk about native integration in Delta RS, how it came about. I'll give also a walkthrough on why this native integration was actually needed. And then at the end, we'll have some time for a demo. We'll go through some use cases such as single table transactions, doing multi-table transactions for Delta Lake. And then lastly, I'll give a nice example how you can combine Dagster and LakeFS for an engineering project. And of course, we'll have room for questions and discussion at the end. So what is LakeFS then actually? LakeFS essentially is an open source project. It's developed by Treeverse, which also has some enterprise offerings. But what they provide is a Git abstraction on top of your object storage. So your object storage in this case can be S3, which can be AWS S3, but it can also be an other S3 compatible API, such as MinIO, Cloudflare R2, but it can also support Azure Data Lake Storage and Google Cloud Storage. And what it essentially does is it links your buckets or containers and manages those within LakeFS. So you would get a managed bucket on S3 done by LakeFS. And then the way that works is you can interact with LakeFS using an S3 compatible API. So it's quite simple. You can use existing clients such as Spark, Polars, object storage in Rust, or even the Python client Opstore, and read directly from LakeFS without actually requiring to have the LakeFS API implemented because they have a compatible API in S3. Additionally, they have the LakeFS APIs and the SDKs. So you have a Python SDK. There is even an experimental Rust SDK. And you also have a CLI tool or a command line tool called LakeCTL, which allows you to do all the Git semantics operations in LakeFS. So you can create branches, you can commit data, you can revert, rollback, you can even cherry pick commits. You can even do tags, so you can snapshot your whole lakehouse data lake with a tag. Almost all of the Git semantics you can think of, you can do with LakeFS, but then with your object storage or data lake. And how this exactly works, you can see on the right. So you have an application. This application then writes data, which goes through the LakeFS server. And then LakeFS writes that actual data into a data directory on that managed bucket. And it also creates some references or metadata in the metadata directory. And LakeFS will figure out which things belong to which branch and which data belongs to which branch. So the benefits, obviously, that a Git abstraction on the object storage would provide is that you can zero copy your entire lakehouse, which can contain petabytes, terabytes of data, just with a single command. So in your main branch in LakeFS, you would have your whole lakehouse sitting. It's just a matter of doing a branch creation from main into feature branch, and you have your whole lakehouse at hand without doing any copy, any data duplication. It's just there. Then another useful thing that then LakeFS gives you because of having this isolation in branches is you have a full isolated workspace to work in. So you can think of use cases where multiple people want to create a branch from main and they want to actually make changes to a production table. Obviously, you're not going to do this in production, so you can do this nicely in a LakeFS branch, make the change, verify whether it actually worked, and once it does work, you might actually merge the data back, or you just merge the code, and then in production, it will actually use that change. Another useful thing is that you would have data version control. So as I mentioned before, you can do tagged releases. You can actually tag your whole lakehouse and make a snapshot of it. And then you can also revert back to it. So you can revert commits. And lastly, a thing that LakeFS provides, unlike other object storage, is a garbage collection. So if you have certain branches that are not being used anymore, we can actually delete those branches. And then after time, we can set up a garbage collection policy that also deletes the underlying data on the object store itself. So let's move on to the type of workflows we can support. So this is one of the biggest use cases that I counted myself in my previous role, and that's where you have kind of a large data science team working on a very large, you could call a monolithic pipeline, but it's still a pipeline with 50 to 100 different assets that all are connected and all are related to each other, and they have an impact into your final model results. And in this situation, in my previous role, we were actually using a different tool, and we didn't have any LakeFS abstraction. So when we created a run, that run would actually create temporary directories, write to that directory for that asset, and that asset would only be valid within that specific run, which meant every time someone is making a change on this whole pipeline, they had to actually execute all those assets sequentially. And it could take, well, for some assets, hours, which meant a lot of time was lost, a lot of compute was lost, and it was essentially a very inefficient process. So now think of this example where you have a very smaller example, but you still have interconnected data assets. You have Jane and John working on the same project, same pipeline. They're both working on different parts of the pipeline and different assets, but they can impact each other. Now it's just a matter of them branching off from main. They have their own individual feature branch where they can work in isolation. And once they're done with it, they can just validate it within that branch and then just merge the code back to main. Another useful workflow it can support is for data scientists and ML engineers. You can essentially create a branch per experiment. So think about the use case where you need to have traceability and accountability for what you trained your machine learning models on. Now it's already in that experiment branch. So it's just a snapshot of your whole lakehouse. And within that snapshot of your lakehouse, you can now also save your model in LakeFS. You can also save the ML features you train it on in LakeFS. And you can actually link this nicely with MLflow. So if you do your MLflow experiments and you're going back to them, you can actually see which branch in LakeFS was used. And then you can just go to that branch, inspect all the data it was trained on. And this is very useful in certain industries such as healthcare, but also military, where you need to have this explainability for your models. So what kind of workflows can it else support? And one is a quite new one, I would say, and hasn't been used. I haven't used it myself that much before, but I think it's very interesting. It's called the Write-Audit-Publish workflow. So think of with normal DevOps, right? You would have your GitHub actions, GitLab CI. You would do certain checks before you actually merge your code into your branch. You can do the same thing with data now. You can actually create a feature branch, you add some data to it, and now you define certain hooks that hook into the lifecycle of your Git semantics. So you can have a pre-merge hook, but you can also have a pre-commit hook, a pre-tag hook. There are many type of hooks you can define in LakeFS actions, and you can think of many use cases with that. So think of a pre-commit hook that actually verifies the content of the commits that you have done in LakeFS. So you don't want to commit certain files, like you don't want to commit YAMLs, for example. You hate YAMLs, you don't want any YAML in your lakehouse, remove them. You can check that with a pre-commit hook. There's also a pre-merge hook where you can, for example, do some asynchronous validation of your data. So this is a feature that Delta Lake, for example, has, but it does it during runtime. So you can use Delta Lake constraints, and you can actually define per column which SQL expression it should validate on before the data is written to the table. And that's very useful. But the only thing is, it's doing it during runtime. So when it fails, the data never got committed to the table, which might make it difficult to debug which data was actually going to be written to the table as a whole. So if you would do this with LakeFS, it's just a matter of that data already sits in a transaction branch. The pre-merge hook failed, so the whole merge failed, and it never merged into main. But now you still have the possibility to go to that old transaction branch, read the table, and debug why is my data invalid, what actually happened. And this is a different kind of mindset than doing it during runtime. You just do it asynchronously.
And not to interrupt, but it'll also keep your vacuuming jobs sort of cleaner. And we can talk about later more about this, but you have much less orphan files because otherwise you would have all those files for you to clean up later on, which you're avoiding.
Yeah, agreed. Yeah. So the last use case that can be very practical, and that's a multi-table transaction setup. So think of a use case where you have a source table, and that source table is going into different pipelines. So different pipelines, they are actually dependent on the same source table. You could make the argument if that source table was corrupted, then all of the transactions of those dependent pipelines, they should also be invalidated at once together. So with a multi-table transaction workflow, you could do this. And you can revert one single commit, which would then revert multiple tables at once.
I want to interrupt for that one real quick.
Yeah.
So if you think about that, right, you're essentially, it's like a reverse lineage, reverse, like kind of like, it's like a rolling rollback across everything else. Is there any like, for people who haven't dealt with like triaging complicated pipelines, like, is there a way to kind of like describe what that looks like or how that usually feels? So now, like as a data engineer, when everything downstream has become corrupted and you're trying to like figure out how to fix it, it can be kind of overwhelming when you could potentially have like a single command that says, okay, we're just going to roll back everything, including like dependent, like, you know, dependent transactions. You wanted to talk a little bit more about that because it's kind of fun to share like the shared, you know, on the job trauma.
Yeah. So there have been definitely cases where it has many different assets, and there was one corrupted asset that actually ruined everything downstream. Quite often you just have to figure out this whole lineage, go step by step. Okay, which snapshot or which version do I have to roll back, up until that last one that got corrupted, and then you would have a clean setup. And with LakeFS, it would just be a matter of, okay, all these tables were in a single transaction together. This was committed in this hash, so we have the commit ID. We just do rollback or revert that commit, and then it reverts all the tables at once together. Yeah.
And this applies to validations as well, right? So nothing hinders you from validating across multiple tables to make sure maybe some things just show up downstream and you can, I don't know, figure this out before doing the actual commit.
Yeah,
Very
exactly.
powerful.
Yeah, exactly. So you can all combine these things as well. All right. So let's talk about the native integration then in Delta RS. And I've been brewing on this this idea of creating a native integration for quite some time. And honestly, I wasn't able to get to it because we're busy with other things, working on other ideas in Delta RS. And also, I didn't know how to actually solve it up until some point. I was quite late. I went back in the train from Amsterdam back to my city, and I just had an epiphany. Okay, this is a way I can solve this. So I just noted it down in my notes, and I quickly started writing all the code in the weekend, and I had a kind of working solution by Monday. So I was really happy about that. So with that backstory, why is that actually then needed? Why do we need that native integration in Delta RS? And I'll explain it by a use case or workflow where if you don't have it, it will fail. You actually need it to get the same level of write concurrency that Delta RS provides out of the box with any other kind of object store. So if you use AWS S3, GCP, Azure Data Lake, you would have that optimistic write concurrency because you can check whether the same commit has been written on the object store. If you do this, however, with LakeFS, you would have the workflow where you would create a branch first from main, which would then create a transaction branch. You write your data in this transaction branch, you commit it with LakeFS, and then you merge your transaction branch into your source branch. But now think of the use case where you have actually two concurrent writers doing the same thing. So both of them, they create a branch from version 0 of a Delta table. They're completely unaware of what the other writers are doing in their own branch. They both write version 1 of your Delta table. They commit it. Both try to merge it, and then obviously one of them will fail because the other one was a bit faster than the other, and it successfully committed version 1. Now we have a LakeFS merge conflict, and we have no clue how to resolve this. Like, you could maybe rewrite that log manually, but that's very tricky, and I think Robert would agree that you shouldn't do that.
Please don't do this. No, please. Or at least don't open any issues after the fact. Yeah.
So it's just not wise to then manually rewrite it. And what we would do before is we would just actually scratch that whole transaction branch and just retry the whole operation. And that's a bit compute intensive because you have to then retry the whole write operation, write that same data again. And it's not very scalable, especially if you want to do concurrent writing. So that's why it's needed. We need to actually fit those LakeFS Git semantics of committing and merging inside the Delta Lake committing itself. So a Delta Lake commit of a Delta log is now kind of logically linked to a LakeFS commit. So let's then go through how this operation and how this whole integration works. It's quite dumbed down, but it's also very simple the way it's implemented. You would start with your operation, and every operation can do a pre-execution through a certain execution handler and do a post-execution. So we start the operation, which is a normal write operation in Delta RS or Delta Lake, or even a merge or any kind of operation you can think of. It starts, it does a pre-execute. This pre-execute creates a transaction branch. Then you just continue as is. You write all of your data in this operation to the transaction branch. Then we write the Delta commit also to that transaction branch. Create that LakeFS commit so the data is also committed into the LakeFS branch. And now we will try merging this transaction branch into your source branch. So let's say I wanted to write directly into main. We'll try to now directly merge this transaction branch into main. But there was actually concurrent writers, so we had a merge conflict. And now we are actually aware that there was a merge conflict inside Delta RS. And we can just increment this commit. So we can do a conflict resolution, say, okay, it's safe to just increment the Delta log by 1 and just retry this whole flow again. So we retry it. It now succeeded because we're the next in line. And now we'll just do the post execution, which will just delete that old transaction branch. And then everything is finished. And we successfully have written to a Delta table with the LakeFS integration.
I just realized we can even circumvent the atomic swap. I don't think we do this right now, and it's not costing us much, right? But we don't even need to do this. We could just write the commit directly.
Yeah, exactly.
Yeah.
I think it's time for the demo then. All right. Just let me know once it's visible, Robert, on the screen.
Yeah. Okay, go ahead.
All right. So I'll first start off with showing single table transactions. And what I've done is I've created a small Docker Compose YAML. And this Docker Compose will spin up our LakeFS server. And it will also spin up a min.io server. So I have my min.io server then as the actual storage layer or object store, and then LakeFS mounting that object storage. So in the Docker Compose, we also already create our medallion architecture. So we create our bronze repository, silver, and gold repositories. And you will also see that we create equivalent buckets in min.io. So let me just spin this up. And it should be live now. We can see the repositories are created with some default branches. Let's switch to here. And you can see we have 3 repositories. We have bronze, silver, gold, and you can also see the namespace. So this bronze repository links to the bronze bucket in min.io, which you can see here as well. Actually, need to log in again. So you can see our 3 buckets, bronze, silver, gold. And in bronze, you can see already a directory that LakeFS uses for the metadata. So let's go to our first notebook. So in this example, we will just create a single table and have a single write transaction to the LakeFS repository using Delta Lake. So we use Podars and Delta Lake. We just import everything here. Then we configure our LakeFS endpoint and LakeFS client and all of our storage options. Then, because I'm working on an isolated feature, which I called new cool feature, I will just create that new branch and branching it off from main. So we'll have a new branch created called feed new cool feature, and I can show you how this looks like in the UI. So if we go to bronze, you can see there is now a new branch called new cool feature. There is still no data in there, but we'll actually write to this in a bit. So we create a data frame, and it says Delta RS is pretty awesome. And then we write to the storage layer. So it's just a matter of providing the LakeFS URI, saying which repository, which branch you want to write, and then lastly, you define the table name. So we have Delta RS magic. We do the write action, And if we go back to our UI, we just have to click refresh, and now we can see the transaction successfully committed. And you can see here's a delta table with a delta log. We have just written this. And you can also see this commit in the commit history of LakeFS itself. So we see the repository was created a couple of minutes ago, and then we did our first transaction. So this is the transaction that's done by Delta RS. It's saying finish Delta Lake transaction for table Delta RS magic, and it committed version 0. So we also mention the version of the committed transaction of Delta Lake in the title of the actual commit itself in LakeFS. And lastly, you can then also merge this branch if you want back into your main branch, or you can just keep your work inside this new cool feature branch. You don't have to do this, but just for the sake of the demo, I'll show you that if you do this, and we go back to our objects, switch to the main branch, and you will see that the data now resides as well in the main branch. And in the commits, we can see the original transaction we did in our feature branch, and we can see that there was a merge commit from the new cool feature into main. All right, so let's go to the multi-table transactions use case I was talking about earlier, where you would have multiple tables done in a single transaction. And it is quite similar to the previous workflow. We just load some of the things. We define our LakeFS client, the Python SDK of LakeFS. Then we create a new branch, again referencing from source, called multi-table transactions. If you go back to the UI, we can see it's created. And you can also see that it now has the data we previously merged into main. So it actually has the full copy from the main branch. As I was talking about before, you can essentially zero copy everything. And if we go back, now let's start writing those two tables. So we have one table here, then we have another table. One will be written with the name first table, and another one will be written with the name second table. We just do the transaction. And now if I refresh here, you will see those two transactions done in this table. And they will be done in separate commits. But if we go back to our notebook, so what you now can do is you can merge this multi-table transaction branch into your main branch back, but you can use a squash and merge type. And this is it's similar to the squash and merge of GitHub. So what it does is it takes all of your commits and just squashes it into one, and it creates one new commit which attaches on the head of the main branch. So let's do this. We also say a new message. So we're saying merging table 1 and table 2 as a multi-table transaction. And then we just trigger this. We also get the commits back. And now if we switch to main, we'll see both of those tables committed, but as a single transaction. So as a single commit. So I can inspect the commit, merging table 1 and table 2 as a multi-table transaction. And I can see that we have written first table and second table. And this is now quite convenient because let's assume there were some issues with the data. We can just roll this whole commit back, and I'll actually have to copy the new reference in here. So you can either do this from the notebook, but you can also just go to the UI, see which commit you want to revert, and you just copy the commit ID. paste it in here. So we say our bronze branch main, we want to revert this commit. But we actually want to revert to this commit. So let's just go back here. Oh, I think I've clicked the wrong one, sorry. Yes, my bad. So reverted now the commit, and if we refresh it, you can see revert of this transaction. So you have committed, and you can see also that those objects are now removed from the object store, from LakeFS.
And I think what people should keep in mind is that you can, well, not while you're writing the data, but when you revert or stuff like this, it should be similarly fast, even if you've written several gigabytes or terabytes of data, right? It's just a metadata operation. Just
Exactly.
go back.
Yeah, exactly. So there's no data movement involved. It's just a metadata revert. Yeah. All right, so let's move on to the final demo. And that's the part where you have LakeFS and Dagster as a singular project. So this is a common workflow I've used before, and that's where you have your Dagster project, which you then use for your data orchestration or data pipelines. And then you use LakeFS as your storage solution together with an underlying object store. So what you would do is you would have a single definitions file which configures your assets. It configures a LakeFS branch creation job, and it configures an I/O manager for Delta Lake. So the important thing is why these things can work nicely together is we'll just add a simple utility function called getGitBranch, which simply parses with Git what current branch you are using. And then when you are in your new feature branch, so I can give this actually in a nice demo, I'll just create a new branch, live demo. So we now have a Git branch called live demo. I can now spin up my Dagster project. And what I want to do is I want to first create the branches in LakeFS that are then logically linked to my Git branch. So I have a job in Dagster that will trigger to create new LakeFS branches based on the current Git branch. And it will use the source reference main. And you can see what this job does here. So it does a LakeFS client, it creates a branch. It's not very complicated. It just goes for every repo that we have defined. We take the repo, we create that branch that we want to create, which is the current Git branch, and we use the source reference main. And if it's created, then it's fine. We just skip continue. If it's not created, then we create that branch. So I'll just spin this up. So we'll just first create the branch, doing create Dagster, create LakeFS branch. And this creates a job or triggers a job which creates these branches in our repos. So it created a branch live demo in bronze, silver, and gold. And if we go back to the UI, we can see that we have this new branch, and we can also see that it was created in the other repositories as well. So now we can just spin up Dagster, the web server of Dagster, and we can actually start executing our assets and writing them in this current Git branch that I have, which is then logically linked to the LakeFS branch. So we can see our deployment here, which is our local venv. We can see that we have two assets here, and we can see in the lineage, we have an upstream asset and a downstream asset. And now I'll just click on materialize all. We'll see a run. And we see that in this run, it materialized 2 assets, the upstream asset. We can see it materialized in the bronze repository, in the branch live demo, in the schema delta demo, and it's called upstream asset. And if we click on the full message, we also added the LakeFS link. So if you click on it, you can actually immediately inspect that asset on LakeFS. So if I go back, then we can also go to the downstream asset. Same thing, same fashion. We immediately materialize the asset. And now we have written it to the silver repository. This button of the sharing is in front of it. And you can click on the LakeFS link again, and we can see that we're in the silver repository and we have materialized this downstream asset. So one thing I really like about this workflow is your work or your code and the changes to your code, they become logically linked to the changes of your data. So if you're working with multiple people on this single project, they can make changes on assets that are then linked from their code branch to that LakeFS branch. And if you then later, in any point in time, need to just go back to, okay, you made this change, what were the changes and how did it look like in your snapshot or your branch? It's quite easy to do this because the branches and the names of the branches are logically linked. So the changes that you are done, you can actually really view them back much easier. And I think this concludes the demo. So I think we can switch back the screen sharing.
Back on screen.
Yeah. All right. So that was about it for the demo. I think we now have plenty of time for questions and discussions. So looking forward to hear the questions from the chat.
Yeah, thanks, Ian. So I can only say, first of all, well done.
Yeah.
Second of all, boy, would have my life been easier had sort of this stack been around a couple of years ago. I think this truly kind of shows us how software engineering and data engineering is converging. And yeah, one thing I used to say is sort of versions give life, right? So versioning is kind of the equivalent of evolution in the data world. And now we have branches and stuff like this as well.
Yeah.
Amazing stuff. I don't know, Scott, do you have something to say? There's a bunch of questions out there.
Yeah, there's, I mean, so we have a lot. I think some of the stuff that like has come up real quick, I think is more on like the security topic as well, right? Where it's like, if you remote, like how, for example, would somebody use this if you have like, you know, if it's not running locally, but it's running, you know, in production? Like, are you just, you know, sending bearer tokens that, you know, provide your, you know, your grants permissions, things like that? What does that kind of common workflow look like? Sorry, like words are hard.
Yeah, so the LakeFS, at least the open source version, it has a quite simple role-based, or it doesn't even have a role-based XML, just a single admin user. Mm-hmm. You can, however, implement your own specifications. So that's a nice thing and friendly thing that they've done. They have provided the full open API specs of what the authentication server and authorization server should look like. So you can implement these things yourself and just hook them into the open source version. But obviously they also have the enterprise offering, which has all these things already covered. And then it's just a matter of, you can provide roles or you can create roles, and roles can have certain access permissions to even on a path level, and I think also on certain activities, whether they can read or also write. So it can become as granular as any other kind of object and then, yeah, it would be quite similar, but you need that offering or you need to set it up yourself.
No, which is completely fine. I think for a lot of people, right, it's like that whole question of like, what does a branch protection rule look like for data within like the same kind of context as Git? So
oh yeah. So you already actually the branch protection rules you can already set up. You can set up certain branch protection rules that you can't directly merge or write to main. So you can block that. You can only allow merges into main. So these things are, I think, already in LakeFS open source. So you can already set that up. Yeah.
perfect.
And you mentioned at some point, I feel during a discussion we had, that there is also external hooks that you can integrate to validate, right? So much like on GitHub, you could call into a service that would inspect or whatever you do, and it's just like an external REST service that does whatever validation you want it to, right?
Exactly, yeah. So there are a couple hooks. It's the REST API, so you can just call any service that you have custom built, which does all the validations. But you can also just use the Lua integration that they have. They have some inbuilt libraries, or they provide some libraries with it. You can even inspect Delta Lake, the Delta log with some of the libraries they've created. And otherwise, you can use Airflow. So you have an Airflow hook. I still need to bring up the suggestion to think about a Dagster hook, because I think that would be pretty neat. But for now, you can have you have these options. Yeah.
Cool.
Awesome. I do remember one question that came up fairly early in the chat that I asked myself as well. So vacuuming. We mentioned before that you actually avoid a whole class of vacuums, which is often files due to completely failed commits.
Yeah.
But is there anything to take care of in terms of vacuuming that's special to LakeFS? Or this LakeFS workflow?
So there's one thing you definitely need to implement, and that's the garbage collection policy. So you need to have a separate service that runs Spark submit jobs that will figure out which files are unreferenced in your managed bucket by LakeFS. So if we would vacuum, then those files become unreferenced, I believe, and then we can just remove those with the garbage collection policy. So the Spark submit job will look at the bucket. There are no references anymore to those data files or log files, and then it's just a matter of that Spark submit job just cleaning it up.
Okay. Awesome. There was another question by Victor. Does using LakeFS have any impact on reader-write performance of the Lakehouse?
I haven't noticed it at all, and I think LakeFS has quite some documentation on this, on performance, on how to scale it up, and they mention, if I remember correctly, you can actually have a quite small service with the amount of resources, and then it will scale up really nicely with the amount of transactions you're doing. And if you just need to scale up, it's just a matter of putting more replicas of the LakeFS instance out there.
Because it would feel like a lot of the jobs sound like they're a lot more just like read heavy anyways, like versus being write heavy, given that you're essentially just writing deltas to Delta Lake anyways.
So there is probably a way to even make it faster. You can set up LakeFS to use pre-signed URLs. So you can just write directly to the storage layer using those pre-signed URLs. So then you would kind of partially avoid going through LakeFS, which also should improve the performance. But it's definitely scalable. I haven't noticed any issues. If there were issues, it was within Azure networking most of the time.
That's fair.
I mean, you mentioned Kubernetes earlier, right? So best chances are you have too many workloads on your node and you're just trying to squeeze everything to a network card that's too small. Yeah.
There was so there's another question from Sai, where it says like essentially like it's the tendency for us to not necessarily trust things, right? And so it's like I'd be more afraid of like, data as a PR. Is it correct? Is it not correct? Right? Like, and you talked before about like the LakeFS like pre-merge actions, and so if you think about that, right, and you have the ability to say like this is high quality or it's not high quality based on whether it's direct constraints in the table or if it's like an externalized like rule engine, right? Like like a Spark expectations, Great expectations, star expectations, DLT like there's so many different ways of doing the kind of same thing, right? But if people are just doing that as for my table, I expect it to look like X for these columns, should be safe, right?
Sorry, Ian, before you go into it, I feel obliged to mention that and that, well, actually you can mention the Delta feature as well, which is your first layer of defense, but just go ahead. Sorry.
Yes, it would be quite easy to do that, right, Scott? So you can have PRs actually nowadays in LakeFS, so that's a new functionality. And it looks very similar to a GitHub PR, and you can define hooks that are running before the PR. So they would do all these validation checks, checking whether the statistics of the data is correct or what you're expecting. And there's also another thing you could do. You could do it interactively. So LakeFS ships with DuckDB WebAssembly. So if you want, you can actually inspect the Parquet files and do some SQL queries on top of it, if you are really scared that the data that's going to be merged is invalid.
But
that's a cool thing.
You can write a lot of these validation rules, essentially anything that you can express at SQL on a column or even tabular level directly within the protocol. So Delta RS, Spark, any compliant implementation will just reject outright the commit if your data doesn't fit that, right? But the LakeFS integration takes this a step further. First of all, from the workflow perspective and automation perspective, I think the DevOps engineers now, right? It's the software engineers that came to data, and now the DevOps engineers can have their field day as well and go crazy on all of this. But you can do this across multiple tables, right? You can do this across a snapshot of your entire data lake now, which is obviously incredibly powerful.
Yep.
Are there integrations with any catalogs, Unity catalog, for instance? Would it be possible to merge to do uses in conjunction with, I don't know, Databricks Managed UC or SSUC?
So this, it's a tricky question. So I know there is an integration with Unity catalog. I think it's only with the Databricks Unity catalog, because the last time I've used it, it's 1.5 years ago. It might now support the open source Unity catalog as well, but there is an integration. It's essentially also a hook. So it's a hook that triggers after, for example, a commit or merge. And what it would do is it would actually register that table on that branch to your catalog. And it will actually create new catalogs on the fly with that. In terms of like Unity catalog covers obviously more formats, but if you're looking at, for example, Iceberg, then I know they are working on a REST API Iceberg catalog. So then that catalog is natively within LakeFS. So you can just query a branch and that will be then a catalog as well.
Maybe for people who like a little bit of context, Iceberg natively has a concept of branches. And I don't know if it's tags also, but branching is definitely built into the protocol. I think tags as well, right?
Yeah.
And obviously that fits nicely kind of on top of that. Although there may be conflicting semantics, but that's beside the point. Awesome. So we have more question. So one question around the Dagster example, and I don't know if you can describe sort of a rough setup here, because it's probably there's a little bit more to it.
Yeah.
But your code being tied to Git, right? That's something that we've seen. But if you execute in Dagster, it's running in a container somewhere. Sort of how does that, let's say, workflow integration into CI/CD work if you're, let's say, devoid of Git and have it deployed somewhere?
Yeah, so this is actually something where a colleague of mine, a former colleague, Stefan, and me worked on a custom CLI that actually does all of these things for you. So you have a CLI which allows you to actually containerize all your code. You just have a Docker file definition. It containerizes or packages everything in an image. And then it also already configures some things like the branch name. And then it would deploy that asynchronously from your Kubernetes Dagster deployment to Kubernetes, and then registers that branch into Dagster. And that's how you could do that setup. I can give you the links of this package if you want to use it. Yeah, so it allows you to essentially have the same workflow. So you would have a CI/CD setup in GitHub, for example. Once you do a merge to main, that will trigger then a stage which will just do Dagster UC, deployment, deploy, and then deploy to dev, for example. And then it would deploy to your dev cluster, package all the codes, push it to the registry, and then set the things up in Kubernetes to actually link all the things together.
And just kind of, it's hard to transport how significant some of this is, but the fact that we are at a point where we can reference everything sort of via the hash, right? So you have tags on your Docker containers, you have commits in Git, you have run IDs in Dagster, you have commit IDs in LakeFS. And you can carry all of this metadata all through your workflow end to end, right? So you can, if you set things up right, everything gets sort of transparent, and you're okay, this thing. I'm not saying it's easy, but it's incredible how powerful this is once you get this visibility into your system. And it all starts with just being able to manage versions of things, right? Of code, of data, of everything, essentially, right?
Yeah.
Awesome. More questions. So there's a question around, or several questions actually, if we can make some of this code available. Sorry to put you on the spot here, but yeah, can we create a repo somewhere where people can look into this?
It's actually already on my GitHub. It's a public repo, so if you just go to it, to my GitHub profile, and then
if you share the link, I'll forward it, and then we'll put it in the comments of everything.
Yeah. Just give me a second.
Awesome. A lot of people are going to be happy about that. Let me see, more questions. Would it allow to do multiple LakeFS commits from a single commit? So I guess triggering stacking multiple commits on a branch and then merging that, if I read that right.
Yeah, definitely. You can first commit some changes, then you write some new data, and then you do LakeFS commit again. And then each LakeFS commit only has the changes from that point in time which you actually committed. So you can stack, you can write a file each time, and then you have a stack of them, and then you can merge them into another branch where you will see the whole stack of commits. But if you want to have a neatly Git history, you can do the squash and merge, and then you would have a single commit on your source branch.
Scott, I don't know if you have an opinion around this, but one thing I am going to say is, please only try this with fairly slow-moving assets, stuff like this. Yeah. If you're going into some of the high-frequency, high-velocity streaming stuff that Scott loves to do, maybe.
Yeah, like no auto-committing, right?
Yeah.
Yeah. Well, I feel like you could do a lot of with the right checks and balances in place, with slowly changing data that's well known. You can do a lot of this wouldn't be problematic like in stream either. But for a lot of the workflows where it's financial or, exactness matters, like this is a really awesome way of being able to ensure that everything is working well. Plus, like a lot of like, I'm like, I'm going to call us all data geeks, right? It's really fun to be able to go through and take a look at all the things that have changed in an easy way versus being like I think one of the big problems in data engineering is like a lack of lineage or a lack of idea of like, how did something actually shift out from underneath me? It's like the whole like, quicksand type thing where it's like, oh no, you're gone. It's like, all right, cool. But like with a lot of like the metadata, like I think that really is the most important part of all of this, because it's like, it's not just lineage to that, runtime ID or the run ID, it's the lineage to everything. And I think that makes, that really like, it does make me kind of giddy, which is cool. It's like, it's a Wednesday morning for me, and I've learned a lot of new things this morning, and that's awesome. Like my day is going to be that much better because of this, like, because it's exciting. I don't know, these are just awesome features. It's also really cool to see like a working demo that doesn't crash. So you did a great job with that, because it's always hit or miss. So
Yeah.
that was awesome.
Awesome. Yeah, I can only second that, right? So at least in my personal journey with Git itself, right, it used to be, I don't know, final 1, final 2, final 3, right? I don't need to tell you. And then at some point you need to remind yourself, no, I don't need to do any of this. It's Git managed. So delete away whatever, you can always go back.
Mm-hmm.
And it makes your life, as Scott, as you said, it makes it easy for you, right? It gives you the confidence to just do stuff, try things out. And with this, yeah, you have something similar for data. And obviously, Delta itself does something similar with versioning, but I think this levels it up to another degree, right?
Exactly.
Yeah.
And you also have the flexibility, right? So you can still do rollbacks within your Delta table, but also do it on another level where you roll back multiple tables at once. Yeah.
Yeah. I mean, if you read kind of Nassim Nicholas Taleb's musings about investing, optionality is one of the most powerful things out there. Just having options and choices.
Yeah.
I think we're running about out of time, or at least approaching time. I don't know. Anybody feel like they want to share more? There's probably more questions out there that I haven't gotten through, but there's so many. We'll try to. So, in case you have more questions, feel free to join the Slack channel.
Yep.
All of us hang out there. Yeah, and we'll be happy to answer any follow-up questions that may arise, and even inspire new talks, right?
Definitely.
I think the one other thing that I was just kind of thinking of was if there is not yet LakeFS support in Unity Catalog, there is an open source Unity Catalog project, and people could, if they felt up to it, go and create that connector and make it work. And then we would have LakeFS support in Unity Catalog as well. So I'm like, that's my PSA. So happy
that would be pretty sweet. That would be really sweet. Yeah.
Cool.
Awesome. Yeah.
Well,
thanks so much for sharing this with us.
Yeah. Thank you for inviting me.
And yeah, see you on GitHub the latest, right? We have some reviewing to do later on today.
We do.
Yes. We have some big plans. Awesome.
cool.
Thanks everybody for tuning in.